In this supplementary lecture video, I am going to go over some big examples of AVL tree insertion and deletion and B tree insertion and deletion. So I'm just going to pick random numbers. Let's say I do 30 for an AVL tree. And then let's say I do 40, and that will become its right child. And then 50. Now I can press pause and skip through in this animation. It's going to go all the way down, and then as it moves up, it's going to check the balance. And then here at the top, we're going to see that we have 2 to the right and none to the left, so we have an imbalance. Now we have to do a single left rotation, like so. So next, I'm going to put in 60. There, it's just going to become the right child of 50, and we don't have any violations. If I put in 55, what's going to happen is it's going to insert as the left child of 60. So now what's going to happen is we're going to get up to 50, and we're going to have our violation because we have 2 to the right and 0 to the left. But the crucial thing is where this number came from. If we move it over like so, we would lose the ordering. So watch what happens. It's going to notice the left right, and it's going to move 55 up. So let me step back. It notices the left right, and it puts 55 as the root, 60 as 55's right child, and 50 as 55's left child. So we finished evaluating the tree. So now I'm going to complicate this further. I'm going to put in 53, and it's going to become the right child of 50. So when we step up here, we're going to notice again an imbalance of 3 on the right and 1 on the left. So how are we going to make this change? The crucial detail that you must bear in mind is that we came up this way. So therefore, what's going to happen is we're going to come up. 50 is going to become the root. 40 is going to become the left child of 50. 30 is going to become, so it's going to remain the right child of 40. Then we do 55, and the left child of 55 becomes 50's old right child, which is 53. And then we're going to have 60 over here. And you see that we have our balance. So let's keep inserting more. I'm now going to do 35. And we are going to come down here. And we see that when we move back up, when we hit 40, we have our 2 and 0 imbalance. And we came from this way, which means we are going to make 35 the new quote-unquote root of the subtree. So 50's left child is now going to point at 35. 35 is going to point at 30 with its left child, and its right child is going to become 40. And you see that we have a perfectly balanced tree. So now let's insert 45. We're going to see that when we insert 45 that we're not going to have an imbalance. And now I'm going to insert 43. And we're going to have our imbalance at the node containing 40. And we're going to have the double right rotation. 43 is going to move up, and 40 is going to become the new left child of 43. Let's complicate things. Let's do 37. And we're going to see here that our imbalance occurs at 35. So we have to remember that we came from this direction. So that means 40 coming up. 40's new left child is going to be 35. 35's right child is going to become 37. 40's right child is going to become 43. So let's step through this like so. So now to see if we can produce, let's do 44, and I'm just going to play it. It's going to get another double right here, and that means 44 is going to rise up, 43 is going to move down, and 45 will be the right child of where 44 is. So 44 is going to come down here, then we see our double right, and then 44 moves up. And so now we have a complete subtree on the left of 50, all of which have a height of 3. And on the right, we have a complete subtree, except it has a height of 2, the tree that begins at 55. Excuse me. So now what happens if I insert 20? When I insert 20, no matter what I do, it's going to create an overflow. And the crucial thing is that it's going to come all the way up at the root. So we see that we have a height of 4 on the left and a height of 2 on the right. The other thing to bear in mind is that we have the left here, which means here's what's going to happen. We're going to see 40 move up to the root. 40's new right child is going to become 50. 50's new left child is going to become 44, so that's over here. The subtree remains the same. 55 and its subtree remains the same. And we're going to see 35, 30, 20, 37. Now, since we have 43 and 45 down here, we're going to see that the height will work out. So if I add in 15 and 10, we're going to see that we get a small rotation. So you see there's a violation here, 20 moves up. And now in order to actually create a rotation again, we're going to need to insert a couple more elements. So I'm going to insert 25, and we now see we have a violation, and we came this way, which means 30 is going to move up, 35 is going to become the right child here, 20 is going to become the new left child of 30, 25 will become the new right child of 25. And now I'm going to insert 10. It's not going to create any height violations all the way up. And we're good. Now I'm going to insert 5. And what's going to happen is it's going to come down here. The height violation will happen at 15, and 10 will become the new root of 20. So now if I insert 4, the violation will happen at the node containing 20. And here's the violation. Remember, it came up to the single left, so that becomes our new rotation there. So now let's see if I can throw this off even further by adding 3. What's going to happen when I add 3 is the violation will occur at the node containing 5. So therefore, we rotate here. So now we have a complete subtree here. So now let's add 2 and see what happens. What's going to happen is it's going to come down here. And let's see where the violation actually happens. Nope. Here's where the violation happens. So now we have, since we came from here, we are going to perform our new rotation. What's going to happen is 40 is going to still remain the root. It's now going to point at 10. 10's right child is going to be 30. 30's new left child is going to be 20. 10's left child is going to remain 4. So let's walk through this step. And so I'm going to insert 1 and then 0. So we're going to go through the same thing. We're going to see the rotation happen at the node retaining 3. 2 is going to move up. So now I'm going to insert 0. Here's the violation, and so forth. So now let's start deleting elements out of the tree. First, I'm going to delete 40. What's going to happen is I'm going to look for the largest value on the left and move it up, like so. Next, I'm going to delete 50. So we're going to move the largest element up. If I delete 45, then it's going to try to move 44 up. We have to make sure that when we delete anything that we are preserving height. So what you're going to notice here is I'm going to try to delete all these elements on the right to eventually produce a rotation. So if I do 55, it's going to move 53 up. And now I'm going to delete 44. And now we run into an issue. We have our 4 and 2. So what's going to happen here is we have our violation, and we came up from this way. So now we are going to perform a rotation. 10 is going to become the new root of the tree. Its new right child is going to become 37. 37's left child is going to become 30, and its right child is going to remain 53. 10's left child is going to remain 2. Like so. And so now let's mess with this on the other side. I'm going to delete 2. It's going to move the largest value up, and we don't have any height violations here. Now I'm going to delete 1 to try to produce one. Going to move up here. We have a violation here, and now I can move to the node containing 4 to be the left child of 10. I'm going to make 0 the left child of 4, and 3 is going to become the new right child 4. So now let's see what happens when I delete 3. Deleting 3 is going to create an imbalance. And it's going to move up, and then it's going to get caught all the way at the root. So the root, we have to go this far. And what happens here is that it picks the larger of the two subtrees. So here we have 3, and here we have 2. So now it's going to rotate. 30 is going to become the new root of the tree. And 37 is going to be its new right child. 37's new left child will be 35. 30's new left child will be 10. And 10's new right child will be 20. Like so. So now I'm going to create some trouble, I'm going to delete 37 and then 35. 37 is going to bring 35 up, and we're going to notice the rotation, the violation, here, and we move that up there. So now I'm going to delete 35. And now if I'm going to delete 53, this is going to create more issues for our tree, but let's solve them. It's going to notice the imbalance. What do I delete? 43. I'll delete 60. Delete 60. It's going to notice one here at the top. And now it's going to go right. We're going to rotate that way. Now I'm going to delete 30. Now I'll delete 4. 4 is going to move 0 up, and we're in good shape. To create an imbalance, I'm going to delete 0. So now we have an imbalance here, and the reason why it did this is because 2 is greater than 1, so it chooses that direction and moves it up. Now we'll delete the root at 20. Moves 15 up, and we're good. I'll delete 25 and then 43. Moves it up, and we're in good shape. If I delete 43, the violation is going to happen at the node containing 15. It's going to perform the single rotation and get the result there. If I delete 10, it's going to move 5 up. And then finally, if I delete 5, it'll move 15 up. And then deleting 15 here will make the tree empty. The next visualization I want you to do is with B trees. So first I'm going to do a max degree 3 problem and then a max degree of 4 problem. I will plan to have on one of each on the final exam. So what I'm going to do is I'm going to pick random numbers and I'm going to start inserting them. Bring it 10 here, and then I'm going to do 15. And now let's say I want to insert 12. What's going to happen here is 12 would be the middle element, and then I'd have 0, 1, and 2. Since it's odd, it's going to move 12 up, and 12 is going to become the new parent in the tree. If I add in 11, it's just going to fill in this key. If I add in 12, here I'm going to pause once it gets here. It's going to say, well, 12 would be over on the right, so 11 would split and go up. So that would be like this. What's going to happen though is that it's actually going to move 11 up here. So it's going to be 11, 10, sorry, this will be, oh, I'm inserting 12 twice. Let me skip back. Just to prevent confusion, I'll insert 11 here, and then I'll put in 9. Now it's going to move 10 up, and normally it would be 10, 9, and 11. Do 12 here, and then 15 here. Since this is not full, it's going to move this up here. So it'll be 10, 9, 11, 12, and 15. Now I'm going to insert 8 and 7. 8 is going to just fill the key with 9. When I insert 7, here's what's going to happen. First, it's going to get here, and then it's going to split. 8 is going to move up, and then 8 would be over here. So now we would split and move 10 up. And now what's going to happen here, this is too big, so now 10 is going to become, then it's going to have its first child point at 8, its second child is going to point at 12, 8's new second child is going to be pointing at 9, it'll have 7 over here, 12 will have 11 and 15. So now I'm going to insert 16 and 17. And now, when I get down to the bottom here, we're going to see that 16 is the middle. So it's going to rise up there. So now I'm going to insert 13 and 14. This will fill up the middle key here. And if I insert 14, so now here's what's going to happen. It's going to split here. It will rise up, and now we have to split again. So 14 is going to rise up again and fill in that second key. If I insert 18 and 19, 18 is going to fill the key down there. So now 19 is going to fill it in, split it up, and now 18 is going to have to go here. And now I'm going to insert 20 and 21 to produce a big split. 20 is just going to fill that key. And now when we insert 21, it's going to go down to the specific key, split and raise. So now 18 is going to go up here. And now we get to this situation, and 14 is going to split and raise. So now let's start deleting elements from this B tree. I'm going to first delete the root, and what's going to happen is it's going to take the value that's the smallest and move it up. But now we have a new problem. Here, 12 and 11, there's only one element here and one element here. So what you're going to see is you're going to see an animation where we have an empty space, and it's going to point to a combined key. And that will be the next step where we identify we have an issue. And so now we're starting to see that we have an issue problem here, because we are going to perform some sort of rotation. We're going to notice that this one's empty, and we're going to see that these two are going to combine. Specifically, it's going to be 8, 10, 7, 9, 11, 12. Right here. Now we have the same situation here. And now if we do the same process, if we combine 13 and 18, where 13's initial child points to 8 and 10, its second child points to 16, and then third child points to 20, then it's going to balance the tree out. And so now we have our new tree. So what happens when I try to delete 18? First, it'll go down here, it will seek out the largest value on the left-hand side, which is 17. So let me run that step again. So it's going to move down here, and now it's going to notice that we only have one element here, one element here. It's going to combine them into 15 and 16, and it's going to have an empty node above it, like so. So now what are we going to do in this situation? How are we going to borrow? So when the element is empty, so let me take a step back. When we can combine here, we are going to see that we can perform that rotation. So now we're stealing the keys, and now we're going to move down. So when we steal the key, what's going to happen is it's going to perform this rotation of pointers. So watch what happens. Moves here, moves here. So let's step forward. We see that this now moves up. And the reason this happens is we step back here. 13 was initially over here, so 13 is going to rotate over. And 13 is going to have 15 and 16 on the right-hand side. But notice how 10 is pointing to 11 and 12, but 10 is going to move up. So in order to make this work, I'm going to make this be 11 and 12, and that's going to be pointing to 10 up here, which is then going to be pointing to 8. But on the left-hand side, we have 7 and 9. To cause more chaos, I'm now going to delete 8. So when we move this, we're going to notice that we can combine 7 and 9 now. And now we have an issue here. What are we going to do in this situation? Well, we can perform a rotation. That rotation is going to be that 10 is going to move down. Sorry, let me step forward. 10 is going to move down. And 13 is going to move over by 1. So watch what happens. We will move 10 down, combine it in a node with 13. The first one's going to be pointing to 17 over here, and 17's second child is going to be pointing at 20. So now 13, we'd have 11 and 12 here. We'd have 15 and 16 here, 7 and 9 over here. So now what happens when I delete 17? It's going to take the largest element on the left-hand side, which is 16, and move it up. In this case, we're fine. So now let's delete 16 and see what kind of ruckus I can cause. Now it moves over here, and now we see that we have a scenario in which we have 2 elements here and can perform a right rotation. So what we're going to do is we're going to see 12 come up and 13 move down. Now I'm going to delete 15. So it's going to cause this, and it's going to notice this situation. So what's going to happen? 12 is going to move down. 12 rotates into 1, and 11 and 12 combine, and now 10 is the root. So let's delete 13. You'll go down here, move it up, and it stays the same. If I delete 11, we're going to see this rotation here, where this value is going to be empty, and this value has 2. So now what's going to happen is you're going to see 7 remain there, 9 will rotate up, and 10 is going to rotate down. So now let's delete 12. I delete 12. It's going to move it up here. Then we're going to see that we only have one element in the left, no elements in the right. So we're going to do that combination here. So now what's going to happen is this is going to be the same scenario here. So now it's going to be 10 is going to move down. It's going to combine into a cell with 20. The first child is going to be 7 and 9. 10's second child is going to become here. It's going to be 19. The third child is going to be 21. So now I'm going to delete 20. So it's going to bring 19 up. It's going to say, well, I don't have an element there, so now I need to perform the rotation. We have 2 elements in this cell, so what's going to happen is 7 is going to remain here, 9 is going to move up, 10 is going to move down, and we're going to have 19 and 21 here. Now I'm going to delete 19. If I delete 19, we're going to move the largest element to the left, which is 10 up, and now we're going to see that we're missing an element here. Then we're also going to see that we're missing an element, that we have this rotation. We only have one element here and 0 elements here. So what's going to happen? Well, it's going to turn out that 9 and 7 are going to combine, and 10 is going to become the new only key in the root node. So let's delete 10. And what's going to happen is it's going to bring 9 up. Nothing else is empty, so it just leaves it alone. If I delete 9, now what's going to happen is it's going to have the empty element here, and then it's going to combine 7 and 21 into a single node. Then if I delete 7 and then delete 21, that will empty the B tree. No, doesn't delete it. Okay. Now let's do a degree of 4. I'm going to insert 30, 40, and 50, and it's going to put everything into its own key. So now I'm going to insert 35. So what's going to happen is that it would put it in this specific order. For even, it's going to be 4 divided by 2 minus 1 is equal to 1. So it's going to move 35 up, 30, 40, 50. So it would pick 35 to move up. So now I'm going to insert 31, 32, and 33. And now I'm going to insert 33. And now to do a split at that same ordering, 31 is going to move up, and it's going to become a new part of the second key here. So this will result in 31 with 30 over here, 32 and 33 here, 35, and then the last one is going to be 40 and 50. Now I'm going to insert 29, 28, and 27. So now it's going to move this over. 28 is going to move up. The new first child is going to be the node containing 27. The second is going to contain 29 and 30. And the rest of the B tree remains the same. So now I'm going to insert 26 and 25 and 24. And now you're going to see the double level split. So first it's going to come down here and it's going to say, well, 25 needs to be moved up. And now we're going to say, well, 28 needs to be moved up. So the way the tree is going to look is that 28 is going to become the new root. Its left child is going to be 25. Second child is going to be 31 and 35. It's going to be 24 over here. This child is now going to be the second child of 25, so this will be 26 and 27. This child is going to be the new left here, so it's going to be 29 and 30. This child is going to be 32 and 33, and this child is going to be 40 and 50. Like so. So I'm going to insert a few more. I'm going to say 23. Actually, I'm going to insert 55. And I'm going to insert 52. 37. So when I insert 37, that's going to make 40 the middle here. And now 35 is going to be the middle there. And now I'm going to insert 56 and 57. This will produce the effect that I want. So now what's going to happen is we're going to get this element here. 55 is going to split up. So now 35 is going to be the element to move up. So now what's going to happen is it's going to move up here into a non-full key. 28 and 35 is going to be the top key. 28's left is still going to be the one pointing at 25. The second element is going to be pointing at a node containing 31, which is going to be 29, 30, 32, and 33. The next child is going to contain 40, 55 over here. This is 37. This one's 50. This one over here is 56 and 57. Like so. So let me insert a few more. 58 and 59. And we're going to see the split down at the bottom fill up here. Now I will do 60 and 61. And we're going to see multiple splits, like so. So let me insert a few more just to produce a real multi-level split. So I'm going to insert 62 and 63. And this is going to produce a split at the bottom, which will move 61 up here. So now we insert two more and we're going to see a full effect. If I insert 64, it's going to fill up the last key. But now if I insert 65, what's going to happen is it's going to exceed the size here. 63 would move up. Now we exceed the size here. 59 would move up, with 57 being the left child and then 61 being the right. But now we have an excess here. So what's going to happen? The element 35 is going to move up. So let me draw the top of the remaining tree. 35 will be the new root. Its left child will contain 28, which will have 31 here and 25 here. 35 on the right is going to have its other child be 55 and 59. First child will be 40. We have 57, and then we have 61 and 63 here. So let's produce that animation. And there is the final B tree. So let's start deleting. I'm going to do 35. And it's going to grab the largest element from the base of the tree. We don't have any issues. We quickly get issues if I try to delete any value here from 33, 28. So now watch what happens when I delete 28. Well, actually, that's not going to cause an issue that much. It's going to bring 27 up, like so. But what happens when I delete 33? It's going to bring 32 up, and it's going to rotate over. So it's going to bring this over. Notice that I have two elements in the left key, 29 and 30. So it's going to move 31 down and 30 up. So now if I delete 32, this is going to cause some problems. It's going to bring 31 up, but now we notice that we have an empty key and the other key is only one element. So we'll try to combine 29 and 30, and now it's going to notice that there is an opportunity for combination here between 27 and 25. And now it's going to notice what's going on here. We see an opportunity here. And it's going to move that over. And now, well, the last question is, where do you come from? Why, how are we going to account for this? As it moves that edge over to be the right child of 31, and now we have a balanced tree. So now let's create a couple more problems. I'm going to delete 55, and it's going to get the left subchild. It's going to get me 50. We only have one value in 37 and 40 with no values in that right child, so we're just going to try to combine these two. Now it's going to say, well, how do I account for this? It's going to rotate 31 and 27 over, and this is going to become the new right child, like so. So now let's delete 27. See that it will try to move up 26. We have an opportunity for a combination here. We have an opportunity for a combination here. We have an opportunity for a combination here. And then that's our full B tree. To torture it a little bit, we're going to delete 57. So 57 here tries to move 56. It notices an opportunity for combination. Moves up here, as can perform the rotation, and now we're going to see this borrowing of edges, like so. Now I'm going to delete 62. Now it notices over here that I've got elements to the right. So let me run through that process again. When I delete 62, see I have more elements to the right and I can rotate. Let me delete 63. When I delete 63, now it moves it up, and it notices that I have an opportunity for combination. If I move this down, if I move 61 down and combine it, now we maintain our height. And you can see how it's maintaining the height throughout the entire tree. So now to cause an issue with that, let's delete 50 and see how it responds. Well, it moves 40 up and everything works fine. When I delete 40, that's going to cause a couple more issues. As we try to bring it up, it's going to say, well, we can combine everything here. And that's going to bring 56 up because there were two elements in the right value. So 56 is going to come up, 37 is going to move down, and that's going to work fine. So now let's delete 56. It's going to bring 37 up. It's going to notice the opportunity for combination. And now it's going to try to figure out what to do here. Well, I have 4 elements. I have an empty value here. So what can I do? What I can do is I can say, form a rotation, and then account for those edges. Now I'm going to delete 59. It's going to move up 58, which is the largest element, put it there. Now I'm going to delete 37. I can rotate this over. So what's going to happen is we see that we have 2 elements in the next smallest child. So I can move it over like so. Now I'm going to delete 31. When I delete 31, it empties it. And what are we going to be able to do here? I can combine 30 and 29 and move it down. Now I'm going to delete 64. If I delete 64, what's going to happen is it's going to move 61 up, and we're in good shape. Now if I delete 61, now we're going to have all kinds of rotations. 60 becomes empty. We see the opportunity for combination. We see the opportunity for combination. So now 26 and 58 are going to fill the root node, and then we're going to have these 3 subpointers become the new subtrees. If I delete 58, it's going to move 30 up, and that will just be the tree there. So now if I delete 30, it's going to initially try to put in 29. So let me step forward and show you what's going to happen here. It's going to notice that we have 2 elements left, 2 elements right. So what are we going to do here? In this particular choice, it always says if I have 2 to the left, go to left first, and then go to the right. So it's going to rotate 25 up, 26 down. So now what happens when I delete 29? When I delete 29, it's going to move 25 up. I'm sorry, 26 up. So it's going to notice an empty node. So what's going to happen is it's going to combine 24 and 25. 26 will be the new root. 24 and 25 will be here. Then 60 and 65 will be here. Okay, I was wrong. My apologies. It's going to move. I know the design choice. It's because there's more elements here, it's going to rotate over. So that means 60 moves up, 26 moves down. Now that we only have one value in each subchild, now it's going to do what I thought we were going to do. Let's delete 25. When I delete 25, it's going to try to move 24 up, but we have an empty value. So in this case, now it's going to combine 24 and 26, and 60 is going to be the root. Now if I delete 65, here's what's going to happen. It's going to notice that there are two elements. It's going to move two elements in the node to the left here. It's then going to say, well, I have one to borrow, so it's going to move 60 down and 26 up. So 26 can be the new root, 24 will be on the left, and 60 will be on the right. If I delete 26, it's going to combine 24 and 60. And then I will delete 60 here.